Good morning, good afternoon, good evening. Welcome to this video where we're going to be unpacking trig on a triangle. It's your boy Mr. Malachi and let's jump right into it. So I call this section trig on a triangle, and you guys are sitting at home thinking, but isn't all trig about triangles? Yes, it is. But particularly with this one, we're going to need to draw a triangle and represent these ratios onto the triangle so that we can further simplify these other guys that are given in the question. So how does the question read? It reads, if cos 20 degrees is equal to t, determine in terms of t what cos 160 is, b what cos with a negative 200 degrees is, what sine 250 is, what sine 20 degrees is, and what sine or 20 degrees is. So how do we go about doing this? First thing we need to do is we need to represent this ratio onto a triangle. So what do I know about cos? I know that cos is adjacent over hypotenuse. That is the fraction of cos. So if I'm given that I have cos is equal, or cos 20 degrees is equal to t, then I can represent that as a fraction, as a t over 1. And this helps me because I know that the t is my adjacent and I know that the 1 is my hypotenuse. So let's represent this on a triangle. So there is my right angle triangle. It's always going to be right angle. I have my 20 degrees there. And if I'm standing right there, what is my adjacent? My adjacent is the side down here, which is a t in this case. And what is my hypotenuse? My hypotenuse is this longer side, which in this case, it's a 1. Right? And now what I need to do is I need to apply some Pythagoras there. And what am I using? Why am I doing Pythagoras? Because I'm looking for this opposite side that needs to sit there. So let me do my Pythagoras. Pythagoras always says hypotenuse squared is equal to the adjacent side squared plus the opposite side squared. So the one I'm looking for is the opposite. I have the hypotenuse, which is 1. I'm squaring that. I have the adjacent, which is t. I am squaring that, and I'm looking for the opposite. 1 squared is just 1. If I take this t squared over, it becomes a 1 minus a t squared is equal to opposite squared. Then at this point, I square root on both sides. And so my opposite is actually equal to this root of 1 minus t squared. So the side here in my triangle is my 1 minus t squared. So now that I've drawn my triangle, I'm then going to use this triangle to actually solve for the other ratios that I needed there. So let's move this triangle somewhere here because we're going to be using it. We've already used this Pythagoras, so we can take this away. Just cancel that. Alright, then now we can start solving these questions. So the first one says, what is cos 160? So that one does not need us to really use the triangle. We just need to use some reduction there. We've done reduction in the previous video, so go check out that video if you don't know how to do reduction. But with this one, all you're going to do is you're going to say cos 180 minus 20 would give me 160. And with this, again, you do need your cast diagram. So 180 minus would put me into this quadrant. And what is cos in that quadrant? Cos is negative in that quadrant. So I end up with a negative cos 20 degrees. And if you simplify this in terms of t, it is just negative t. Right? Where am I getting that? If cos 20 degrees is t, then cos 20 degrees, if I just substitute the t here, then it will be a negative t. I hope you guys see that. All right, let's do the next one, B. So B says, what is cos negative 200? So what we should remember is negative angles for the sine and for the 10. If I have a negative angle, it gives me a negative ratio. But with the cos particularly, it just gives me a positive ratio. So this ends up being a cos 200. And then that I just need to reduce again, which is 180 plus 20 in this case, and plus 20 degrees. 180 plus puts me in this t quadrant, and cos is negative in that quadrant, so I end up with this guy, and this guy is again a negative t. Hope you guys are seeing what's happening there. And then C, we have sine of 250 degrees, right? So again, let's reduce this. I'm going to use 270 to reduce it. So 270 minus 20 would give me back to that 250. And remember, with the 270 and the 90, the ratios always change. These are your co-functions. So the sine changes into a cos, and a cos would change into a sine. But where does 270 minus put me? 270 minus puts me into this quadrant, and sine is negative in that quadrant, so you end up with a negative cos 20 degrees. So do not forget to change the fact the sine into a cos. So it's a negative 20 degrees, and for that I just put a negative t. It is again a negative t, right? So these were very easy. They just needed a little bit of reduction. D, on the other hand, which is asking us what is sine 20 degrees, this one will need the diagram. First of all, let's remind ourselves, what is the ratio of sine? Sine is always opposite over hypotenuse. So what does this tell me? It tells me just go onto your diagram. What is your opposite? My opposite is this guy right here. Hope you can see the opposite is this guy right here, and my hypotenuse is that guy right there. So I just need to put that as a fraction, as a ratio. It's going to be the root of 1 minus t squared divided by a 1. Right? And this you can simplify as just 1 minus t squared, all underneath the root. All right, that is D. And then E asked us what is tan 20 degrees. So now let's remind ourselves, what is the ratio of 10? The ratio of 10 is O over adjacent, opposite over adjacent. So again, we go onto our diagram. Go onto our diagram. What is our opposite? Our opposite is this guy, and our adjacent is this guy. So I just need to represent that as a fraction. So I end up getting root of 1 minus t squared divided by t, and that you cannot simplify. Let me just erase a little bit here so that it's clear what am I writing there. This is 1 minus a t squared. That you cannot simplify, so you leave it like that. So that is how you go about solving these type of questions. So let's look at another example of these. Alrighty, so in this example, we're given that if sine 40 degrees is equal to P, write in terms of P what sine 140 is, what sine 220 is, and what all the others are. So again, we need to draw that we need to represent that ratio onto a triangle. So there's my right angle triangle. I have 40 degrees there. And so remember what sine is. Sine is, so if it's sine of 40 degrees, is equal to P, this is actually as a fraction a P over 1. And what is sine. Sine is O over H, adjacent or opposite over hypotenuse. So where do I label my P? My P would be my opposite, and my 1 would be my hypotenuse. Then I use Pythagoras to complete that triangle. So Pythagoras always says hypotenuse squared is adjacent squared plus opposite squared. So my hypotenuse I do have. My adjacent is what I'm looking for. My opposite is the P, and it's squared. 1 squared is just 1. So if you take the P to the other side, it's a negative P squared, and it looks like that. And so what is adjacent by itself? Adjacent is therefore equal to 1 minus P squared. So now I represent this on my diagram. And there we go. So my diagram is now complete. I can use that diagram to find the other ratios. So let's start with A. A says, what is sine 140 as a ratio? Sine 140, I could just reduce that guy as being sine 180 minus 40. And for this, I do need my cast diagram. So there's my cast. Where does 180 put me? It puts me into this quadrant, and 180, and sine is positive in that quadrant. So this ends up being a positive sine 40. And what is a positive sine 40? It is just equal to a P. I hope you can see that. And B, we have sine of 220 degrees. Again, I'm going to use my reduction. That is 180 plus 40. 180 plus 40, where does it put us? It puts us into this quadrant. And what is sine in that quadrant? It is negative, so I get a negative sine 40. And this is just a negative P. There we go. So let's do the next one. C. What is sine negative 140? Remember our negative angles, the sine and the tan will become a negative ratio. So this tells me that this becomes a negative sine with 140. And then this is just me doing some reduction again, which is 180 minus 40. And that puts me into the quadrant where sine is positive. But since I already have a negative out there, I'll end up with the negative sine 40. And this is just easy a negative P. I hope you guys are seeing that. And then D, we have cos 50 degrees. So once I see cos, I'm thinking there's going to be some co-functions that need to come in there. So what I'm going to do is I'm going to do cos 90 minus 40. 90 minus 40 puts us in which quadrant? This quadrant there. So remember, if it's cos, it changes into a sine. But since they're all positive there, this ends up being a positive sine 40 degrees. And this is just equal to a P. And there we go. I hope you're seeing how these are working. And then E, I would recommend that you pause the video and try some of these yourself. E is sine 50 degrees, right? There's two ways of you doing this. Sine 50 degrees, what I need to do in my diagram here, you could do co-functions and reduce it and change it, or you could just realize that, oh, if this is 40 there and this is 90, if I do 180 minus 40 minus 90, then this will most certainly be 50. Then what does this tell me? It tells me now I'm sitting at that point. This is my reference angle now. And now what is my opposite when I'm sitting there? My opposite would be this guy. And what is my hypotenuse? My hypotenuse would still be the 1. So that guy is actually O over H which is actually the root of 1 minus p squared over a 1. That's one way of doing it, right? Another way of doing it is you could say sine 50 degrees is actually reduced to be sine 90 minus 40 degrees, and that becomes a positive cos. Remember, they're all positive in that quadrant, so it stays as a positive. And if it's a positive cos 40, then you're standing here. And what is your cos? Cos is adjacent over hypotenuse. And what is your adjacent? In this case, our adjacent is that root of 1 minus p squared over a 1. And this you can just simplify as 1 minus p squared without the division by 1. So there are two ways of you doing this. You could either do this route, or you could try and represent it on your diagram, and it will be the 50 degrees up there. That's just another way of doing it. Then let's do the last one. The last one is asking us, what is 10 to 20? Again, we're going to need to do some reduction there. That is 10 180 plus 40. And that puts me in which quadrant? It puts me into this quadrant where 10 is already positive. And so this stays as a 1040. And 10, remember, is O over A. Opposite over adjacent. So I go on to my diagram. Where is my opposite? This is my opposite if I'm standing at 40. And this is my adjacent. So you end up with a p over a root 1 minus p squared. This is your final answer. And there we go, guys. These is how you go about solving these. Let's do another one last question on these. Alrighty, so this next question says if 10 20 22 degrees is equal to t, right, in terms of t, all those other ratios there. So what we're going to do first is we need to draw a diagram. So there's our triangle, right angle triangle, always a right angle triangle. I have my 22 degrees there. Firstly, what is 10? So 10 22 degrees equal to t over 1. We always need to represent it as a fraction, because why? Because 10 is O over A. So this tells me that the t is an opposite. It tells me that the 1 is an adjacent. So let me label it there. So what is my opposite? It is the t, and my 1 is the adjacent. Then now that I've represented it on my diagram, I do need to do Pythagoras to find the hypotenuse. So hypotenuse squared is equal to the adjacent squared plus the opposite squared. Hypotenuse is what I'm looking for. I have the adjacent, which is 1. I have the opposite, which is t, and I end up getting a t plus a 1 plus t squared. That is hypotenuse squared. But if I root on both sides, my hypotenuse is actually equal to 1 plus a t squared. So that's this guy that needs to sit here. 1 plus a t squared. And guys, you cannot simplify that. You can't take that root and get a root 1, or rather simplify it into a 1 plus a t. No, it just stays like that, right? So now I can go back onto my questions and start by solving them. So let's do A first. So A says, what is 10 202? We're going to do some reduction. That is just 10, which is 180 plus 22. And we do need our cast diagram. So 180 plus puts me into this quadrant there. And what is 10 in that quadrant there? 10 is positive, so this ends up being a 10 22 degrees. and that is just easily equal to a t. So that is A. Let's do B. B says what is 10, 3, 3, 8. Using my reduction, I see that is 360 minus 22. Right? And if I do 360 minus, which quadrant does it put me in? It puts me into this C quadrant. And what is 10 in that quadrant? 10 is negative in that quadrant. Let me rather write it here. 10 is negative, so this is negative 10, 22 degrees. And that just is simply negative t. And there we go. So let's do C. C then says what is 10, negative 22. Remember our negative angles, the sine and the 10 will become a negative ratio. So this becomes a negative 10 of 22 degrees. And that is just simply a negative t. Then D, we're given 10, 518. So what I'm going to do is I'm going to reduce it, but I'm going to reduce it using the law or the principle that if I subtract 360, it will put me back in the same quadrant. So let's do that. Let's check. What is 518 minus 360? That just gives me 158. So let's say 10, 100, 518, sorry, minus 360. Nothing really happens to the ratio because, again, it takes us from the same quadrant, does a whole rotation, puts us back into the same quadrant. So this just stays as a 10, 158. Nothing happened to the ratio again. Then now this I do need to reduce. This is 10, 180 minus 22. 180 minus puts me into this quadrant, and 10 is negative there. So this is 10, 22, negative 10, 22, which is negative t. And there we go. Then E, let me check what is E asking. E is asking what is cos 22. So what is cos 22? This one does need the diagram. So we go on to our diagram. Our cos is adjacent over hypotenuse. And so what is my adjacent? There's my adjacent, and this is my hypotenuse. So as a fraction, that guy ends up being a t over a 1 plus a t squared. And again, you can't simplify that, so you leave that as your final answer. All right, I hope this makes sense. This again is called trig on a triangle. And this next video, I will be doing trig identities. And then from there on, we're going to pick up on trig equations. So good luck on this. I hope it made sense. I will see you on the other side. Bye.